Hello and welcome back. In this tutorial, we will show you how to add a component to the component library. So let's start off. First, make sure that no designs are open. Under the Tools menu, select the Component Library option. This opens the Component Library dialog. You can enter transformers, capacitors, diodes, zeners, and inductors into the library by selecting the appropriate tab. In this example, I will show you how to enter a core which is not present in the component library. First, select the Transformers tab. Click the Add button. This opens up a dialog through which you will be required to enter the required parameters. Let's give a name to the core as EF16-Custom. Check this box if this core should be used only for DPA switch designs. Since we intend to use this core for top switch and tiny switch designs, let's leave this box as unchecked. Under the part number option, let's enter the part number. I'm going to enter E16/8/5. Let's leave the manufacturer as generic for now. Now, let's enter the core parameters. Before that, let's take a moment and understand what each of these 7 variables mean. What we have here is the front and top views of one half of a EE core. This is what two core halves look like when they are joined together. The cross-section of the center leg is what defines parameter A sub E. LE is the length of the magnetic path as shown here. AL is a parameter that is material dependent and can be obtained from the data sheets of the core. AW is the window area as shown here. The product of the window area AW and the cross-sectional area A sub E define the power processing capability of the core. That leaves us with the other 3 parameters required in defining the core. This is the front view of a vertical bobbin. The parameter definitions remain the same for horizontal bobbins also. Parameter BW is the bobbin width as shown here. The parameter LT stands for length of a single turn and is literally the length of a turn going around the bare bobbin. This parameter is used in estimating copper losses in the windings. That now leaves us with the final parameter, which is BFW. This parameter is the bobbin fit inside the window and is used by the software to determine whether or not core halves fit around the windings. Many times this parameter is not listed in the datasheets and should be manually measured. A good approximation of this variable is made by dividing the window area AW by the bobbin width BW. With this explanation, let's enter the parameters relevant to the EF16 core. The A sub E for this core is 20.1 mm square. LE is 37.6 mm. AL value from the datasheets is 980 nanohenry. The window area AW is 21.6 mm square. The bobbin width BW is 9.4 mm. The length of a turn LT is 31 mm. And I am going to approximate BFW as 2.25 mm. There, we have just entered all the parameters associated with the core. Every new core must have at least one bobbin associated with it. To add a bobbin, click this Add button. Enter a part number, manufacturer, and orientation of the bobbin. Enter EF16, and since this bobbin has 4 primary side and 4 secondary side pins, I am going to associate a P4 plus S4 tag with it. The manufacturer will be generic. The orientation can be horizontal or vertical. In this case, the orientation is horizontal. Parameter BWW is the same as bobbin width and will be 9.4 mm in this case. The built-in margin on the left and right hand side is the distance from the winding area to the pins. In this case, the distance is greater than 3.2 mm on both sides. I will enter the total number of primary and secondary pins for this bobbin as 4 and 4. Click OK. It is important to point out here that every core you add into the library must have a default bobbin associated with it. If not, the software will not consider this core while it generates the results. In this case, the default bobbin is actually the previous placeholder, so I'm just going to delete it. And then make sure that the bobbin we just added has a tick mark in the checkbox next to it. This signifies that this in fact is the default bobbin for the core we had entered. And then click OK again. And finally, click the Update Library button. There, we have just added a new core into the library. Notice that this core has a user tag associated with it, as it is a custom core and it will go into the user library and not into the default library. Let's do a quick design to make sure that this core will be considered by the software. Let's go ahead and close this dialog and do a quick tiny switch 3 based design. Let's leave the universal input voltage range and let's add a 5 volt 500 milliamp output. For this design, I'm going to use the defaults that the software prompts. The one thing I would like to point out here is that under the component sets, make sure that you either have all records chosen, or if you're using custom component sets, then make sure that the part you added, the EF16 core, is included in that custom set. Please see the tutorial on custom sets for details on how to create and use your own custom lists. For this example, let's select the All Records option and then we'll click Finish. In the Solutions filter, we can see that under the core end, the EF16-custom core does show up. And so it will be considered by the software while computing the solutions. Let's go ahead and click OK and let optimization present its solutions to us. Let's open up a design to view its details. We do hope that this tutorial has been helpful to you. Please visit the Power Integrations website to view more tutorials. Thank you.